So for this problem, we have an urn that contains 6 red marbles, 7 white marbles, and 6 blue marbles. A child randomly selects 3 without replacement from the urn. And for the first part of this, we are asked to find the probability that all 3 marbles are the same color. So to approach this problem, we need to first examine how many or what types of combinations of marbles will lead to all 3 being the same color. So from what I can tell, it looks as though you could get all 3 red marbles, all 3 white marbles, or all 3 blue marbles. So let's examine those events separately. So let's start with getting all 3 red marbles. So the probability of getting all 3 red marbles is equal to the probability of drawing a red marble on round 1 times the probability of getting a red marble on round 2 times the probability of getting a red marble on round 3. So individually, the probability of getting a red marble as your first marble that you draw is simply the total number of red marbles, which is 6, over the total number of marbles, which would be 19. So in simple probability, we say that this is the total number of outcomes that you want over the total number of outcomes that are possible, assuming all of these outcomes are equally likely. So this is the probability, 6 out of 19, to get a red marble on round 1. We now need to multiply that by the probability of getting a red marble for your second draw, given that we already got a red marble on our first draw. Well, remember, this is without replacement. So because we are not replacing these red marbles, there is not only one less marble in the bag, there is one less red marble in the bag. So now the probability of getting a red marble on our second draw is 5 out of 18. Both of these values decreased by 1 because there's one less marble and one less red marble. And you might be able to tell where this is going. If we want to figure out the probability of getting a red marble on our third draw, well, now there's another marble missing from the urn and another red marble missing from the urn. So there's only a 4 out of 17 probability of getting a red marble on your third draw. But remember, we need all 3 of these events to happen one after the other. So in order to do that, we say the probability of this and this and this. So when we have 3 probabilities and we need them all to occur one right after the other, assuming it's possible for all to occur one right after the other, we just multiply these probabilities. So we are going to multiply 6 over 19 times 5 over 18 times 4 over 17. And if you do that, you are going to get roughly 0.02064, which is about 2%. So there's about a 2% chance that this specific sequence of events will occur, getting a red marble on your first, second, and third draw. Now we could repeat this for blue marbles, but there's also 6 blue marbles. So these calculations are going to be exactly the same for the blue marbles. It's going to be 6 out of 19, followed by 5 out of 18, followed by 4 out of 17, which is also going to give us the same probability of getting 3 blue marbles in a row of about 2%. The only one that's different here would be the white marbles, because there's one more white marble than there are the other 2 color of marbles. This probability is going to be slightly different. So the probability of getting 3 white marbles in a row is going to be the probability of getting a white marble on our first draw, which is going to be 7 out of the total number of marbles, 19, times 6 out of 18, because there's one less marble and one less white marble, times 5 out of 17. And that probability, if you multiply those 3 events together, because you need all of them to happen, that is going to be about 0.03612, which is about a 3.6% chance of that one happening. Now, this still doesn't answer our question because we need to find the probability of the 3 marbles being the same color. Now, that means any one of these 3 events can happen. Either you get 3 red marbles in a row, 3 blue marbles, or 3 white marbles in a row. Well, if it's okay for this or this or this to happen, the general rule of thumb is that you can just add these probabilities. So we just have to add this probability and this probability and this probability, not multiply. And when we add these 3 probabilities together, we get a total probability of 0.0774, or roughly a 7.7% chance of occurring. So that's how you would do part 1 of this. Part 2 says find the probability that none of the 3 marbles are white. So let me give myself some room here. And remember, the probability that none of the 3 marbles are white. Now we have to approach this a little bit differently. We are going to use the same formula, but remember, we want the probability that none of the 3 marbles are white. So before we go multiplying these probabilities, we need to figure out how many marbles are not white, because we are going to multiply the probability that the first marble is not white times the second marble being not white times the third marble being not white. Well, if you look into this urn here, you're going to see that there are 12 marbles, right? That's the 6 red and the 6 blue marbles. Those 12 marbles are not white. So there's a 12 out of 19 probability that you will draw a non-white marble on the first draw. And if you draw a non-white marble on the second draw, given that this was successful, that means there is 1 less marble in the urn and 1 less non-white marble in the urn. And then if you repeat that for the third draw, now there are 2 fewer marbles and 2 fewer non-white marbles. And if you multiply these 3 events, because we needed all 3 of these events to occur, that would be about 0.227, or roughly a 22.7% probability of this happening.